For these three questions, we need to use the chain rule, the product rule, and the quotient rule. So let's see, for this first one, this is really something raised to the to the 1/2 power. Square root is the same as something raised to the 1/2 power. So when I take its derivative, I'm going to take that 1/2 down, and I'm going to leave that inside totally alone. Sine squared x minus cosine x, well, maybe need a little more space, cotangent x. And where it was raised to the 1/2 power, I'm going to reduce by 1 that power, and it's raised to the negative 1/2 power. And then I need to multiply by the derivative of the inside, so I'll leave that whole thing inside the parentheses. The derivative of sine squared x, well, I'll have to use the chain rule there too. Bring the 2 down, leave the sine x alone, raise it to the 1 power, times the derivative of sine x, which is cosine x, minus, now if I want the derivative of cosine x cotangent x, I've got to use the product rule. So I'll have cosine x left alone times the derivative of cotangent x. The derivative of cotangent x is negative cosecant squared x. So there's the first piece. And this whole thing is going to be in parentheses because I want to distribute that negative. Plus, let's see, I'll leave the cotangent x alone, and you multiply by the derivative of cosine x, which is negative sine x. And I'll finish this bracket right here, and I'll finish this one right here. Now, you could definitely simplify this, and if this were a test, you probably should simplify this. If you're plugging it into something like WebWorks, some online calculator, it's not necessary that you simplify. But let's go ahead and just leave it like that for now. So here, we're going to use the power rule, the chain rule in here, and we use the product rule to find the derivative of cosine x cotangent x. Let's look at this next one, f prime of x. So here the outside function is 3, so I'll bring that 3 down and leave the x to the 4th minus 4 over cosine x plus 5 totally alone, and change the power to a 2. And then I need to use the quotient rule to find the derivative of what's left inside. The quotient rule says the bottom left alone, cosine of x plus 5 times the derivative of the top. The top would be, its derivative would be 4x cubed, minus the top left alone, x to the 4th minus 4, times the derivative of the bottom. The derivative of cosine x is negative sine x, and the derivative of 5 is 0, all over the bottom squared. So I've got this cosine x plus 5 quantity squared. Again, we could simplify some of this if we wanted to. We could combine the 2 cosine x plus 5s here and the 2 cosine x plus 5s and have a cosine x plus 5 to the 4th on the denominator if we wanted. But that's not really what we're practicing here. We're really practicing using things like the chain rule and the quotient rule. For this last one, we've got 2 functions multiplied by each other, square root of x and tangent to the 4th x. So we've got to use the product rule. So I'll leave the square root of x alone, and then I need to multiply by the derivative of tangent to the 4th x, which would be 4 tangent cubed x. Oops. So I brought the 4 down, changed the power to a 3, and then I need to multiply by the derivative of tangent x, which is secant squared x, plus, then I'll leave the tangent to the 4th x alone, and multiply by the derivative of the first function, which is square root of x. Its derivative is 1/2 x to the negative 1/2, because square root of x is the same as x to the 1/2. And there's the answer. And again, this could be simplified somehow, but if all we're doing is plugging into some sort of online checker or web work, this is a fine way to do that.